Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on reading tables. So, I can't drive 55. An insurance agent reviewed the records of drivers at 12 different ages. By the way, let's talk about that 12. So, they're telling me my sample size right here is 12, and degrees of freedom for regression is n minus 2. So that should say n minus 2, n minus 2. So in this case, it'd be 12 minus 2. So the degrees of freedom is going to be equal to 10. And we notice there it is. All right. So that's our degrees of freedom. Not that they ask and not that that's important at this point. Just wanted to talk about it to see if there was a relationship between driver's age and the percentage of accidents. So right here, we have our two variables. Now we don't know really which one is our X and Y yet. The data table and printout of the regression is provided below. All right, so we'll go find our most important word. We know our most important word is constant. And we know directly below that is our slope row. And because of that, we know that our explanatory variable, which is what the very first thing they're asked for, is age. So we can go ahead and write that there. And I'm going to go ahead and highlight that in pink because it's on the slope row. Now, let's go back to the top. We said driver's age, we highlighted, we underlined that. We now know that that is our X variable. And percentage of accidents is our Y or our response variable. All right, so this is our Y variable. That's going to be important when we go to write our equations. The next thing they ask for is the y-intercept. Well, clearly the y-intercept is going to be on the y-intercept row. And our y-intercept in this case is 64.73845. 64.7384. I'm just going to take it to 4 decimal places. Then our slope will be on the slope row. And it's directly below that. And we'll notice, we need to pay attention to this, that our slope is negative. All right. And our slope is a negative 0.9606. Again, taking it to 4 decimal places. We're looking for the standard error of the slope. So we know that's going to be on the slope row. And we see that it is 0.0540. And there it is on the, oops, that's letter D. Letter D on the slope row. The next thing it asks for is the regression equation. And on our regression equation, I'm going to write it two ways. I'm going to write it as a y hat. So y hat equals, and we start off with the y-intercept, which is 64.7384 minus, not plus, excuse me, minus 0.9606, and we just put an X there. Now, the way I prefer to write that is based on our variables. Well, we just said percentage of accidents, all right, is our Y. So I'm going to go ahead and just put a percent accidents. And just like I have a hat on this, I need a hat on this telling me it's an expected variable. All right, and this is my Y equals 64.7384 minus 0.9606. And we know that our X variable, as we said right here, is age. I'll go ahead and put an X there. All right, the next thing is our T statistic for a slope. Well, the fact that these next two say slope, we know that they're both going to be on the slope row. And the T statistic, as it turns out, is a negative 17.7889. That's letter F. And it turns out both p-values are zero, but we really want the one on the slope row, so I'm going to put a G by that so we know that that's where it came from. And it's 0.000, all right, or approximately zero. Coefficient of determination. First off, we can look all over the table and we'll never see those words, but we will see R squared, and R squared happens to be our coefficient of determination. So, but I have two of them. We'll never use the R squared adjusted in this class. So in this case, it's 96.93%. Next thing I'll ask for is the correlation coefficient. So we need, the very first thing we need is the sine of the slope. So when I go look at the sine of slope, I find out that it's negative. So I have a negative square root of R squared. So we'll go ahead and put that negative down. So we know our slope is negative because that comes from right here. And we're going to take the square root of R squared. So the square root of 0.9693, and we'll drop that into the calculator. 0.9693. Oops. And raise that to the half power. We end up getting 0.9845. So our answer is a negative 0.9845. Kind of squish that together. And please remember, this is all related to the R squared, square root of R squared, and then the sine of the slope. The next thing is the standard deviation of the residuals, and somewhere on the paper there's going to be an S. All right, so we're looking for an S that's kind of by itself, and here it is up here. So 2.9916 is our standard deviation of residuals. All right, I'm going to pause this for just a moment. Anyway, I paused it a moment to input this data. So I went ahead and input the table into L1 and L2. So there's a 1749, et cetera, all the way down. And I want to go ahead and quickly show you once again that there's a relationship here, just in case you've missed that. If I go stat, test, linear regression, t-test, which is letter F, and press not equal, and then right below it, alpha trace, I end up getting my t-statistic showing up at negative 17. This is e to the negative ninth, which is essentially 0, which is what they have here. My degrees of freedom is 10, because my sample size was 12. My y-intercept is 64.7. My slope is negative 0.96. My standard deviation of the residuals is 2.9916. R squared is 96.93. This is 0.96. They just turned it into a decimal. We don't have the correlation coefficient, but we actually did record it down here at a negative 0.9845. All right, I just want to show that there's a relationship between what you're doing on the calculator and what you're reading for the computer printouts. All right, that takes care of this video. I look forward to seeing you on the next one. Thanks for watching.